Hello friends, in this video I will be talking about KNN. We call KNN as Supervised Nonlinear Classifier. After the end of this video you will have a clear understanding that why these terms had been framed in this manner. So let's explore this particular program. Well, I'm using the iris dataset. Here is the one which you can see. We all know that the iris dataset consists of 4 features and we have got one label. So that means these 4 features combined, I will be getting the following class of a flower. The iris dataset comes up with 150 record where 3 different class of data are provided, and each class has been provided with 50 tuples each. So over here Satosa has got 50, Versicolor has got 50, and Virginica has got 50. In that way we have got 150 total number of record in iris dataset. So let's see what are the requirements we have got over here. What are the packages we need to give a call? Well, first I need to give a call to Pandas, because Panda will be responsible to read the dataset, and here it does. So once this reading has been done, the entire data set 150 tuples get saved inside this multi-dimension memory representation. So I wanted to check the shape of this memory representation so that it actually matches with the data set. So data set shape I have printed over here, as you can see, in the form of a Python tuple. It comes up with 150 number of tuples we have got, or 150 number of record, and total number of features. Total features is 4 and 1 target, so 4 plus 1 is 5, so that 5 has been given over here. The 5 total number of columns we do come across, and here are these. So that means it has correctly figured out the shape of my data set. Now what we need to do is that we have to separate these 4 features under one particular memory representation, while I will keep this target or species as another memory representation. So that's what we are doing right over here. So how do we split the data? So the data is over here. I go for the dot function, and the target I'm removing. This particular column name I'm removing. So this is called target. That's what I'm removing. So I'm removing it column wise. Hence my X, capital letter X, represent only 4 of these columns, excluding the last one. Don't worry, I will check the shape even. In the same manner, what I'm doing is that I'm creating the Y representation that would contain only the target. So here I mentioned that I need to copy the content of the target column, and that is Y. And that's what I'm doing. This one is the one which I'm referring over here. So now let's go and check that after the split, what shape did we obtain. So X, look over here, has got the same number of tuples, rows, but the column, if you see over here, has been brought down from 5 to 4. Similarly, my Y representation, it has just got only one column, and that's the reason why you can see comma over here. It means that it has got only one column and 150 rows it has got. So that's what we are getting after the split has been done successfully. So now we are moving to the very important part, and that is called it's very popular, train test split. What do I mean by that? Well, I have got total 150 record. Now I cannot use this entire 150 record. So for that reason, what we will do is that we are going to break down this 150 record into a certain portion for training purpose and a certain portion for testing purpose. So how do we achieve this? With the help of the train underscore test underscore split, where I'm passing 4 arguments. The first argument is my X. That means it has got 4 features. The last one, that means Y, it holds the last column, right? So here I'm mentioning my size. So I will be using 30% for testing purpose. That means for training purpose I will be using 70%, and I am holding the random state as 0. So once we fire this particular function, that means certain chunk of record will be assigned for training, certain for testing, their associated label data for training, and their associated label data for testing. So that's how these four representations we all are getting once we execute this particular function. So now let's check how much number of rows has been allocated to this xtrain once we have done the split. Remember, 70% is going to be assigned for training purpose, so and 30% will be assigned for the testing purpose. So for xtrain and ytrain, that means for these are the four features and this is the label data, how many number of rows this 70% really mean? 105. So 105 rows will be assigned for training with four features, and 105 number of rows has been assigned as a single column for training. Similarly, the leftover 45 number of rows has been assigned for xtest, and 45 number of rows with single column has been assigned for ytest in the form of ytest. Got it? So this is something what we have to do in context to every supervised algorithm. So now let's move on to something which is very interesting. And here comes my constructor. And that's what brings us to the classifier. I told you that this is a supervised nonlinear classifier. So what do I mean by supervised? What I mean is that when we give a call to this particular line or constructor, what am I doing over here? Well, it is creating an instance of type k nearest neighbor classifier, and this is a reference that it got created, and I am passing a argument in the form of number of neighbors. So I will be using 3 neighbors over here, and then we give a call to the function which is very popular known as fit. Let's stop over here for a while. What exactly am I doing right over here? Well, it is supervised, but when I say it is supervised, there is a slight difference between KNN in comparison with linear or logistic or even SVM. There is a slight difference. What is the difference? In case of KNN, it does not create any mathematical formula during this learning phase. So fit means it is a learning, right? So at this point of time, what it does is k nearest neighbor will just create a memory representation of its features and its associated label. I repeat, it does not create any formula like in context to linear regression which creates a formula. But over here we are not creating any formula, rather it is meant for just storing purpose. So fit function will store it data. The data is over here. That means it stores this 105 rows with associated 4 features. It will associate that in correspond with this particular training data. It will store this entire information in a form of a multi-dimension data structure inside the memory. So it is just been used for storing purpose and not to draw any mathematical equation out of this, which we often see in case of other supervised algorithms. So that's where the difference comes. So here we have to keep it in mind that fit function will actually be used just in context to the storing purpose. So it will just keep a memory representation in the form of multi-dimension data type. Great. Now what happens when we go for predict function? So I'm passing over here my xtest. So that means I'm passing 45 number of rows and one column I'm passing. So what does this test will do or predict will do? Well, it already had the memory representation. Now when we are passing the xtest, it will try to calculate the distance in correspond to 3 nearest data point. So that means whenever it picks up a new data set, it will just compare that data set in association with this 3 nearest neighbor and to figure out that which class gives you the majority count. So it will count the given data in correspond to this 3 nearest neighbor and try to figure out that the count which one is maximum. or you can say who has obtained the majority of vote in correspond to the number of neighbors. So over here nearest neighbor is 3. So in association to 3, that means 3 different neighbors it will pick up. In correspond to that, this particular new data, it is been represented under which majority count, and that's what it will store. And that's how this predict function is going to work. So predict function is again going to return me information of 45 rows only, because I have passed over here 45 data. Got it? Sorry. So once the prediction has been done, now we have to go for comparison between the actual y test with that of y predict. We need to compare this to see how much the model has able to figure out that. So what is the accuracy rate? So the accuracy rate will be tested with the help of accuracy underscore score function, where I'm passing the actual data in form of y test and the predicted result in the form of y predict. So the accuracy has been represented over here in the form of 0.98%. Now why this is 0.98%? Why not 100%? That we need to figure out, and that will be easily clear with the help of confusion matrix. So when we pass the confusion matrix, we are passing again the actual y test, the actual data set, and y predict. So in the confusion matrix, what we can see over here is 16. Okay, by the way, it is divided into 3 columns. Why is so? Because you need to keep it in mind, the first column represents Satosa. That means you can think of this way: the 0th row or the 0th column represents Satosa, first row and the first column represent versicolor, and the second row and the second column represent, or the third row or third column is like, if you represent in form of 1 2 3, then it will be third, and if you represent in form of 0 1 2, then this will be second. The second row and the second column represent Virginica. That's how it has been put forward in the form of 3 dimension. So why it is 0.98? The reason is 16 rows has been correctly figured out to be the first label data, that is called Satosa. The next label data versicolor, 17 has been figured out correctly, 1 wrongly figured out as Virginica. So there has been 1 wrong prediction. Got it? So 17 rows has been successfully figured out in the form of versicolor, but 1 row has been there, or 1 record has been there, which has been labeled as Virginica, which is actually incorrect. So that's the reason it's 1 over here. And finally, Virginica, 11 rows has been successfully predicted as Virginica. They are neither Satosa nor versicolor. So total number of record, how many is there? So 16 plus 17 plus 1 plus 11 will give us 45. But out of that 45, if you go for the correct prediction, then it is 44. So now what you have to divide? What you have to do? 44 divided by 45. It would give you approximately 0.97777 something. So round up to that, we would get 0.98. So that's how it is generating. Okay. So with the help of confusion matrix, we can figure out that why the accuracy rate is this. Okay, so over here I have gone for saving my model, I have gone for loading my model. This is something extra which I am doing it for my other purpose, but this is something optional. And now let's come to the new data point, what prediction it would do. So here I'm passing a new data point in the form of a list, which is going to be converted into Pandas data frame. And these are the 4 columns which my features actually belong to, which we saw right over here. Sepal length, sepal width, petal length, petal width. That's what I have to pass again. So it creates a Pandas data frame, and that is the new data point, and here I ideally want to predict. So previous prediction was based on the actual data set, but this is absolutely new data point which I'm providing. So again I'm giving a call to the predict function, and my model has successfully able to classify that this new prediction belongs to the type called Satosa. So if you go and check that this type of data actually represents Satosa, that you can figure out. So later on, if you just do some modification, and then might be you come across versicolor. Okay, so if you see over here, versicolor actually comes with 6.7 around. So if you represent a similar data type, so there might be some change in the type of class. So finally what we realize is that it is why it is non-linear. The reason is that there are three different class of data that we are working. So we will not get a straight line just like the way we do it in case of linear regression, or we will not get a plane like in case of SVM. So this would have a curve shape, and that's the reason why it is called nonlinear. And finally, it can classify that the new data point belongs to this particular class. So that's how it is supervised nonlinear classifier. Remember one thing, KNN at the time of learning phase, at the time of fit, does not create any mathematical equation, rather it just stores the data within its memory in the form of a multi-dimensional data structure, and that would be used to predict in the form of calculating the distance. It can be an Euclidean distance, whichever distance type it is going to perform, and find the nearest data point in correspond to the number of data point we have mentioned over here, and whichever count is found to be the largest, the data will be labeled accordingly. So that's how KNN supervised nonlinear classifier working. Well, here I did not go for matplotlib visualization, that I would do in my next video, and I believe this is clear to you all. Okay, thank you very much. See you soon. Bye bye.